let's solve the problem in detail. First, let's calculate what is the optimal level of consumption of the drug for any price P. That's going to be given by the maximization over x greater or equal than 0 of the experience utility induced by a level of consumption x, substituting the expression for experience utility, we get that is maximized over x greater or equal than 0 of 2 square root of x plus w minus px. Now, this is 0. This is a problem that we have encountered many times and you know how to solve, so I'm just going to skip the details, and we get x optimal as a function of p is equal to 1 divided by p squared. Now, let's compute what is the behavior as a function of tau, and of course the price is p. So that is going to be equivalent to maximizing over x greater or equal than 0 the decision utility induced by x. Now, the key to solving the problem correctly is to specify carefully the maximization problem here. So this is going to be maximized over x greater or equal than 0. Now we substitute the decision utility function, which is 20 square root of x plus the amount consumed of m, that is w minus p plus p times tau x. Why this? Well, because if the drug costs p dollars per unit, then this is the amount that is cost to buy it, and this is the value of the ad valorem tax. Now let's solve the problem. Think of this as the benefit function. Think of this as the cost component, and we're going to maximize. So we're going to get that the first order condition, we're going to see that the marginal benefit function is equal to 10 over the square root of x. Now that because the marginal benefit at 0 is infinity, we're going to have an interior solution. So this is going to be equal to the marginal cost. And we know that the marginal cost is just p plus p tau. If you do a little bit of algebra, this implies that x star of tau comma p is equal to 10 square divided by p square over 1 plus tau square. Aha! But now we have our eureka moment. Notice what happens when tau becomes 9. When tau becomes 9, this term becomes 10, and these two things cancel, so the demand becomes 1 over p squared, which is exactly the optimal. So we have that x star of tau 9 comma p is equal to x optimal. So we have our solution. Tau has to be 9. Now notice something that is beautiful, which is the tax that has to be introduced to correct this large gap between the decision utility and experience utility function is 900%. 900%. That's one big tax, that syntax that needs to be used in this example.